Imagine total green technology that would allow us to travel with solar power on a light beam with a laser light craft anywhere on the planet in 45 minutes without burning oil. Travel into Earth orbit to the space station in a few minutes, or to the moon from Earth orbit in a few hours. Thanks to Dr. Lake Mirabeau at Rensselaer Polytechnic Institute in Troy, New York, this technology is now a reality, with working laser lightcraft models actually flight tested at White Sands, New Mexico. The next step is to move satellites and human passengers into Earth orbit and around the planet at relatively low cost.
Right now we're flying on a 10 kilowatt laser, CO2 pulse laser at White Sands missile range. The current altitude record is 233 feet. But if someone were to make a 100 kilowatt laser, 10 times the power, now we could go to much higher altitudes. The currently flying laser lightcraft is what I have in my hand right here. In fact, it's 50 grams, fully loaded with some ablative rocket propellant. This is a pusher laser concept. The laser comes from behind and hits this highly reflective mirror. It's a parabolic mirror, and it puts the power inside the lightcraft here, and it expels a blast wave out of the back, which pushes it up in pulsed mode. This is a near-term example of what we'll be scaling up to much larger dimensions to push a satellite into orbit. That might be a meter diameter. In the future, we'll have several meters diameter vehicles that will have humans in them, and they'll be flying in kind of a tractor beam system.
Imagine this spacecraft sitting on the ground. All right, you have a laser beam transmitted to the vehicle, all right, and it hits this series of reflecting mirrors, which reflects the power into the engine and then underneath the spacecraft, creating a series of explosions that lift it off in a rotary pulse jet mode that accelerates this vehicle through the speed of sound in just a few seconds.
Current rocket propulsion and space shuttle technology burns tremendous amounts of fuel during liftoff to place payload into Earth orbit at very high cost per launch. Dr. Mirabeau's beamed energy propulsion system, however, is totally green, does not burn fossil fuels or explosive chemicals, or contribute to CO2 emissions and global warming. An energy-efficient ground-based or Earth orbit solar panel power source could provide thousands of laser lightcraft launches at the cost of just a few shuttle launches.
If we had an infinitely reusable engine, and the engine is the most expensive part of it, you could imagine that you could amortize the cost of many flights on that infrastructure.
To enhance laser lightcraft and beamed energy propulsion to a much larger scale, a solar panel infrastructure power grid must be developed, both ground-based and on Earth orbiting satellites, to power up the laser propulsion systems. However, laser lightcraft could fly today with a larger laser power source at several hundred megawatt capacity and with a superconducting magnetic energy storage system. A solar panel ground-based power grid, if developed, would be expensive, but would have the added benefit of supplying a major portion of the U.S. electricity and total energy requirements for the future. It would dramatically reduce greenhouse gas emissions from power plants, dependence on foreign oil, and reduce the effect of global warming. Once the ground-based and satellite solar power infrastructure grids are in place, laser propulsion could become a reality for improved and efficient transportation around the planet, into Earth orbit to a space station, and for future space travel to the Moon, Mars, and beyond.
So this is like building a highway to space, like building an international railroad system or an interstate highway system, a new railway, whatever. You have to invest in the infrastructure, and this is very different than the thinking at present. You've got an expendable launch vehicle, a rocket, it goes up, we don't use it again. Or in the case of the shuttle, it launches, you refurbish 40 to 50% of it, and then you fly it again. We have to get down to the point where these spacecraft are as reusable as today's airlines and are just as safe, if not more safe. That's what has to happen.